This is a brief overview of the FDA Recalls app on Algorand. The first thing I'm going to do is set up my sandbox environment for nightly. The reason I'm using nightly versus testnet is nightly has an indexer and testnet on sandbox does not have an indexer. If you wanted to run this in the mainnet, you would just do sandbox up mainnet. While this is loading, let's look at our two scripts. We have our main script. Then we have our indexer script. The main script has three functions. Wait for confirmation, which is a utility for waiting on a transaction confirmation. Parse into JSON function. And our third and final function is the send note function. The first function, wait for confirmation, and the second function, send note, both are found in Russ's tutorial on Algorand, how to read and write to a transaction note field using Python. We're using Python here. We've imported the Algo SDKs for Python, and we've also imported JSON base64 and request for our parse into JSON function. The parse into JSON function is a function that grabs the API results from FDA and places it into a JSON note. We use these parameters here, the two dates, the two date timelines, and then the recall type food. And then we find the URL number, which is the max amount of API results that these three parameters pull. Hence, we don't have a limit number here, but our URL number, we add it to our URL, and that becomes our new limit. In this parse into JSON function, after we've updated the results based on our new URL, we extract the results only. So we get only the API results that we need, not the meta data that's at the top of the API request. We remove these four keys to keep the data under 1 kilobyte. We loop through and remove them here. And then to find the number of results with the index starting at 0, we grab our URL number and then we minus it by 1. And here in a second, we'll debug to find the URL number. And then the results location, we can do 0 to 12. So we can do 0, we can do 1, we can do 10, we can do 12, but we'll start at 0. And then the end of our function returns the JSON note with the prefix of FDAF. So now that our sandbox has uploaded, we are going to export one of these accounts to find the 25-word passphrase. So we'll do sandbox goal export account, and then I'll grab the first one. You can grab any one of the three. Oops, did the wrong command. Goal account export account. Okay, here's our 5-word passphrase. We're going to grab this and we're going to paste it. And now we want a receiver address. So I'm just going to use one of these other accounts. I'm just going to use the third one here. You could use the second one or the third one. I'm going to paste it. Okay. Now let's debug so we can find the parse final value so we know what range this can go to. Does it go to 100? Does it go to 10? Let's see. So we debug, run the debugger. So parse final value, you see the dates here, you see what we removed, the meta total JSON, we see the recall type, and then the URL number here is 13. So we know we have 13 results. But with the index, it starts at 0. So we know you need a -1 because it goes 0 to 12. Not 1 to 13, it's 0 to 12. So we'll exit the debugger. We know it's 13, so then the parse final value -1 would equal 12. So let's first send one transaction at the 0 index of the API results. So we're going to grab the results from the 0 index at the API, and we're going to add the prefix FDAF on it, and We're going to send the note, and then it's going to decode the note here. So let's run it. So there's the address we got from our private account list, our nightly account list. And then here's the decoded note right here with the prefix of FDAF. And then here's the B64 encoded note. And the way we know it's B64 encoded note is here. We set the JSON note equal to the function, which returns our JSON note. And then we encode the JSON note into B64 and set it equal to the note in the send note function. So let's see what round this was confirmed in. Confirmed in the 50th round. And there's the decode note. So let's send one more transaction. We'll do the 12th index of the API results, and then we'll send this one. Same address as before. Should be a different transaction ID. So we were confirmed in the 62 round on this one, and then we were confirmed in the 50th round of the last one. And here's the B64 encoded note. And here's the decoded note with the FDAF prefix in front of it. And you see the cities are different, so these are two different API results. So now that we've sent two transactions over the private network, we want to index those transactions based on this FDAF prefix that we added here in our parse into JSON function right here, Okay, so let's flip on over to the indexer. Here we have our indexer, and we found this information in the indexer documentation on Algorand's website. We're going to do our prefix as FDAF. And if we look, we had round 62 and round 50. So let's see if our indexer pulls both those rounds with those transactions. So let's run the indexer. Indexer is pretty fast, so here we see our indexer. Current round 78 is when we indexed. And then we have the confirmed round of 50 with our first B64 encoded note. And then we have the current round of 62 with our second B64 encoded note. So that's a quick overview of how to read and write to a transaction note field using Python, but we were able to pull the API food recall results from FDA's website and place that encoded into the note of a transaction, and then we prefix the said transactions, and then we use the indexer to search those transactions with that prefix. And this would work on the main net, not the test net in the sandbox environment, but if you have a node connected, I'm sure it would work in the test net. And that's everything.